Hello, and today I'm gonna talk about the sorting in C++. So first, what is the sorting algorithms? Sorting algorithm is used to rearrange a given array or list elements according to comparison operator on the elements. The comparison operator is used to decide the new order of elements in the respect data structure. That means sometimes we have a insert the data and delay the data, and just we need to sort. For example, see this one, see the website Geeks for Geeks, Geeks, FORGEEKS, and convert to the EEEE because E is the smallest element in this array. That means we need to sort. For another examples, in the class, maybe we have a 60 students, and the final exams, everybody's score is different. So we need to sort who's the best and who's the worst, and who's number one, number two, number three, until number 60. That means we need to sort, right? And the first one, let me go with the selection sort. Okay. So a selection sort algorithm sort an array by respect finding a minimum element. That means in the element, for example, like this one, in this element, there's 5 elements. Start with 0 to 4 in the array, and we need to find the smallest element from the part to putting it at the beginning. So beginning is the smallest one, and the second one, third one, fourth one, fifth one, which is the last one. And the every sort is a different comparison. But final way is the same way. Just sort, find the smallest element, and the second, the third one until the last one. That's the sort. But every sort is a different. I'm gonna talk about some details of the sort. Okay. So the first comparison. See this number 64, 25, 12, 22, 11. So find the minimum element in the array from 0 to 4 in this array. So which is the first one? First one is 11. So 11 go with the first one. Okay, we got the smallest one right now so far. So we just skip the first element, go with the second element, which is the element 1 in this array. So start from the second one. So right now we only have a 25, 12, 22, 64. So which one is the smallest one? Okay, bingo, 12. So 12 is the second one, and the third one is a 22. Yeah, right now let's go with a 3. We already got a 2, right? So go with a 3. So 22, 25, 64. Who is the smallest one? 22. So 22 keep it, and 25 and the 64. That's the what is the sort? Selection sort. That's a selection sort. Actually, I don't like selection sort. I think selection sort is kind of slow. Yeah. There's another examples of complexity, complexity. So things we learned: data structure, a discrete structure. We need to know the time complexity. So omega n times 2 or something. That's the selection sort, which is pretty slow. Okay. Okay, right now selection sort. Okay, let's see my code. Okay, let's just go with one by one. So first one, IO stream, because I have input and output, and the vectors, just dynamic array with abilities itself automatically when it element is inserted or deleted. So which just like a dynamic memory array, something like that. And C time, that's why I use C time, because the current time just to the string, convert to the string, because I use the time, because the sort complexity. And the last one is kind of useful. I use this one a lot, like CSTD, LIB, something, the library. So I Google search uh, some interesting about this library. The first is dynamic memory management. The second one, I can get the random number generation. Um, if I have uh, a bunch of numbers, random numbers, so then I can sort which one is the fast. So yeah, that's helpful. And the sorting and the searching and converting, that means helps a lot. I need I need a sorting in this program. I need a searching in this program, and the converting too. Okay, I'll go with my sort. Selection sort. As I said, selection sort. Go find the smallest one. Remember. So which one is the smallest? Smallest element in this array. So I use two for loops, and the first just until the size, for example, start with 0 and until the size, maybe the 4 or 5 or something, just 4 or 5, minus 1, because that's the what is it called? The index, the array index. For example, I have a 5 elements, minus 1 is a 4, but in the index start from 0 to the 4. That's why, and I plus plus integer mini, because I need a minimum, so that's why I declare a integer mini equal I, and another for loop, integer j equal to I plus 1, and array size 2. If array is mini, go with the another minimum element. So just keep finding the minimum elements in this array. Okay, and got the pointer temp or something, and that's my selection sort. Okay, next one, second one is the bubble sort. So bubble sort is the same thing with selection sort. Just find the smallest one and the second one, third one, until the last one. And let me see, what is that? In the bubble sort, the different with the selection sort is just compare the first two elements. See this one, the algorithm compare the first two elements. For example, I have the number 5142A. No matter what, I just focus on the first two elements so far. Okay, so 5 and 1, compare which one is smaller. 1 is smaller than 5, so 1 go with the first, 5 go with the second one. And I already got the first element, so go with the second element. Second element is 5 and 4 right now. Okay, 5 and 4, compare two elements, which one is smaller. So 4 is smaller than 5, so so 4 with go with the second one, and compare third one, 2 and 5. 2 and 5. 2 and 5. Who is the smaller? 2 is smaller. 2 go with the previous one, and compare the last one. 5 and 8. And who is smaller? 5 is smaller. So go with the first. Go with the previous one. And this is the first pass, and the second pass, and the third pass. That's kind of I mean, use time. This use a lot of time. Well, waste a lot of time. Max. Sorry, my dog's barking. And the second pass, because the sort is not finished, right? See, the last sort to 1, 4, 2, 5A is not finished, right? And because 2 is smaller than 4, but it's still on the next element of 5 from 4. So it means we have the second pass, and the second pass just keep comparing two elements for each steps. 2 until the third one. Personally, I don't like this sort because it's a kind of slow bubble sort because there's a lot of paths, in the code. Let's see the code too. So the bubble sort. So for the first thing, first for loop, all the first for loop are the same. Yeah, just with the start with 0 and until the size -1, the last element just looping through the loop, and the second loop the same thing until, because we just only compared first two elements. That's why I need the second for loop, size and the plus, and the third one, if array index j plus 1 smaller than the array j, means for examples like j in this index probably like the third index, and this one probably like the second index. If the third index smaller than the second index, so go swap positions. That's the bubble sort. Okay. And right now go with the insertion sort. Insertion sort is a simple sort algorithm, and it works similar to the way you sort playing cards in your hands or something, and the array is virtually split into a sorted and an unsorted part. Algorithm, see the algorithm and examples. Okay. To sort an array of size in the ascending order element from the array first the index 1 to the array in index n over the array, compare the current item key to its the previous one, the predecessor. That means the previous one. If the key element is smaller than the previous one, compare it to the element before, move a greater element once. That's the insertion sort. For example, see there's how many? 1 2 3 6 8. So 8 elements. So 3 and 4. That's a different with the previous sort. With the bubble sort, the difference is in the insertion sort we compare with the second element. It's not the first two elements. Compare with I'll go find the second element and compare to the previous one, and go find the second element, compare with the previous two elements, until so far, so on, like that. Max. And just like that. For examples, see 12, 11, 13, 5, and 6. Let us loop for I equal to 1 second element for the array to 4 last element to the array I equal to 1. Since 11 is smaller than 12, move 12 and insert 11 before 12. That means just compare. It's not compare. Go find the second one. Second is 11. 11 go with the previous one, and the 13 go with the 13, and the 5 go with the first one, and the 6 go with the second one. This is the election sort. Max. And with insertion sort. Insertion sort. The first loop are the same. Start. That one's different because start with the is a 1, because start with the second element. Start with the second element, and until the next one. It's not start from the 0. Start from the 1. That's the difference. And integer array equal to array j, and the integer I equal to j minus 1, because I is the previous element of j, and use the while loop. I greater than 0. The while loop means from the I greater than equal than 0, the loop starts, and that's the end. Array element 1 greater than the value, so with a loop. Basically, I mean, you can Google the all the code, the sort code from Google, but I mean, you can understand everything, but I mean, after that, you can copy from the Google. That's easy. You can copy, but you know how to use it. That's the key. Okay. Next one is a quicksort. Next one is a quicksort. Quicksort is the best sort, for my opinion. Okay, the time complexity is the fastest, and I always pick the first elements as a point. Always pick last elements as a point, and pick the random as a point, and pick the medium. You know, in this sort, it's kind of like a tree. You know, we sort like a tree, like a binary tree, a binary search tree. So first thing first step, go find the around the 70th, the last element. Go find the last element. Is the 70. So 70 goes with on the top of the tree. So that means 70 is the point of this sort. So there's a bunch of elements smaller than 70 go with the left, greater than 70 go with the right, and so on. And the last and the next step is see, the 10, 30, 40, 50. The last element is 50. So who is smaller than 50 go with the left. Who is greater than 50 go with the right. So nobody go greater than 50. So 50 is self. That means just keep it here. And then 90, 80 something, you know, the final result just like that. The final result probably just like 10, 30, 40, 50, 17, 80, 90, just like that. It's easy. So 10, 30, 40, 50, 80, 90. So go with this way. So 10, 30, 40, 50. Don't forget 70 is right here. And 80, 90. That's a quicksort. I think quicksort is the fastest sort. Maybe in the future, if we got a job work, so use a lot of quicksort. And the next one is a merge sort. Is a faster too. Merge sort, like a quicksort, is a divide, and the algorithm. It divides and the into array into two ways, just like the tree. You know, go find the one and go with the left and the right. You know, so let's see. To sort merge sort, use merge sort. The key, the second merge sort is 1. See the following implementation for detailed following. In the merge sorts, for example, see the code. In this element, first one's 38, 27, 43, 3, 9, 82, and 10. Go find the medium one. Who is in the medium? Who is the middle? 3 is the middle. So who's the lefter than 3? Go with the left one. Who's the left than right than 3? Go with the right. Right, just divide by 3. Okay, 3 is a point, but the first element is include the 3, so 4 and 3, so it's totally 7 elements. The first on the left is 4 and the right is 3, and just compare each things too. And the next step, see the first one is 38, 27, 43, and 3. Next element, just 2 go with the left one, and the 2 will go with the right one. Go find the smallest one, and the smallest one go to the left, and the bigger one go with the right. So see the sort 38, 27. So compared to 38 greater than 27, go with the right, and 3 and 42. So in the last four, so 3, 27, and 38, 43. Okay, and the right thing, right side is gonna be the same as 9, 10, 82. So for the final sort, it is 3, 9, 10, 27, 38, 43, 82. Okay, so basically I just use a 5 sort yeah, in the program, and see the code too. Yeah, search and sort and the quit sort. See the quit sort, and the code quit sort and the merge sort is a kind of a difficult, but they're faster. I mean, so that means I code a lot. Coding a lot. So the quit sort, first thing, if the left smaller than the right, go with this function, and the while loop, and another while loop if the while loop something, just array index equal to x. Yeah, that's my quick sort function, and the merge sort function too. Merge sort, yeah, and output something. Let me output, okay. G++ sort cpp. Let me output. So original, I have 10 elements total. Okay, so the first one is 17, 29, 13, 26, 42, 16, 48, 26, 30, 30. You can see everything is random, and it's not sorted yet. Okay, see the smallest one is 17, but the 26 still in the first, in the fourth one, and smaller than 30, but it didn't sort. Okay, this is the original code. And see my selection sort, bubble sort, insert, search and sort, quick sort, merge sort, everything's right here. So from the smallest element to the largest element, that means that's the 5 sorted in this program. And another thing need to explain is the time complexity. The time complexity. Who's the fastest one? I think the quick sort is the fastest one. In the average, time complexity in the quick sort is n log, and the worst is still faster than the no in this chart maybe the heap sort is the fastest one, but we don't use the heap sort in this program. And the merge sort is the faster too. Merge sort and the quick sort, two sort is the are both the fastest sort. And the insertion sort, bubble sort, selection sorts are kind of slower than two sorted. Okay, and yes, that's it. Yeah, that's it. Okay, thank you.